What's going on, everybody? Got another video here for you. It's on exponential and logarithmic functions, and all this is a review. Okay, I'm not trying to teach you this. You should already know it if you're in applied calculus. This is just a quick review over some basic topics with logarithms and exponential functions. All right, so let's go ahead and get started. So here we have y equals the log of x with base b means b to the y equals x. So all this is showing you how to convert from logarithmic form to exponential form and exponential form to logarithmic form. So look, it's really easy to do. I think the best way to remember it is you see the base of the log, that's the same as the base of the exponent. Okay, so all you're doing is you're starting here with the base, and it's b raised to the y equals x. You're just going over and back across. So b to the y equals x, and that puts it in logarithmic form for you. And I wrote this problem wrong. That should be a 2 right there. All right, so let's look at this. Convert to exponential form. So remember what I told you. You start with the 3, so it's 3 raised to the second equals 9. So that's just 3 squared equals 9. And that's exponential form. And then here, convert to logarithmic form. So the way I like to do this is I write log, and then remember the base of the exponent is the base of the log. I'll leave a little space here, put my equals, and remember it's 4 raised to this power. See, remember it's 4 raised to this. Well, what's my exponent? It's 2. And then that equals, and then that's 16 for the log. Okay? So, just a quick review on that. All right, let's go down here. Graph. Now, how do we graph these things? Now, all I'm doing in this video is graphing very basic functions for exponential, and then we've got a basic logarithm function. So here we have, we want a graph, so we're just going to make up a table. And you want to choose about 5 points, 5 x values. So we'll choose 0, 1, 2, -1, -2. Now, you can choose any number you want for x, but it's best to just choose numbers that are easy, numbers that's not going to make it big. See, like, in other words, if we chose x to be 5, then 2 to the 5th, that's 32. So you would have to plot the point 532. You don't want to do that. Keep these numbers small. And also, you want to pick some numbers where it makes the exponent negative. What that's going to do is that's going to help you get a good shape of the graph. It's going to give you a good idea what the shape of the graph looks like. And basically what I want to do is I want to choose x values so that my exponents are 0, 1, 2, -1, -2. And after we work this, I'll show you something else that'll clear that up more. But this is basically what you want your exponents to be. Do you have to do that? Absolutely not. It's just the easiest. So all we're doing now is we're just plugging each of these x values in. So here I get y equals 2 to the 0. Remember, anything raised to the 0 power is 1. And then I've got y equals 2 to the 1st, which is 2. Y equals 2 squared, that's 4. Y equals 2 to the -1, which, remember, that's 1/2. Y equals 2 to the -2, which is 1 over 2 squared, which is 1/4. Remember, if you have a negative exponent, you can look at these as being fractions and just move it down to the denominator, and it changes the sign of the exponent. Let me make that 4 a little better. All right, so we get 1, 2, 4, 1/2, and 1/4. And so now all we're doing is we're plotting these points, 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4. 3, 4. Each of these marks are 1. So we plot the point 0, 1, 1, 2, 2, 4, negative 1, 1/2, negative 2, 1/4. And there's your graph. Now, the one thing that you need to make sure of, you do not draw this graph like that, where it crosses the x-axis. Remember, this graph will never cross the x-axis. It's going to get close to it, but it'll never cross it. All right. Now, let me show you this. Let's suppose we're finished with this problem, but let's suppose we had this. I'm not going to graph the function. I'm just going to show you how to pick the x values. Let's say we had 2 raised to the x minus 1, and I've got my x, y, and I need to choose some x values. Well, I want to choose 1, 2, 3, 0, and negative 1 for my x values. And why is that? Because look, when I plug the 1 in, what's 1 minus 1? That's 0. See, that's going to give me 2 to the 0 like over here. If I plug 2 in, 2 minus 1 is 1. That's going to give me the 1 like here. If I plug in 3, 3 minus 1 is 2. So that'll give me like the 2 squared. If I plug in the 0, 0 minus 1 is negative 1. That's going to give me that exponent. And if I plug in negative 1 minus 1 is negative 2. So that'll give me the exponent of negative 2. That's what I was talking about when I said I want my exponents to be 0, 1, 2, negative 1, negative 2. You just pick your x values so that when you plug them in, those are the exponents you'll get. Okay, and then it's all worked the same from there. Then you plot your points and draw your graph. All right. Now, let's look at this. We want to graph y equals log of x with base 3. But before I do that, let's come down here and go over some properties. Okay? All right, so let's look at the exponential properties. Anything raised to the 0 is 1. Okay? So anytime, no matter what the base is, if you raise it to the 0 power, you get 1 as an answer. Here we have b to the u times b to the v is b to the u plus v. If you're multiplying, you have like bases, you add the exponents. Here, b to the u over b to the v is b to the u minus v. If you have like bases, you're dividing, you're subtracting the exponents. And then if you have b to the u, and then all of that's raised to a power out here, you multiply the exponents. And then we have the log of 1 with base b is equal to 0. Anytime you take the log of 1, no matter what the base is, you get 0 for an answer. Now, these properties here, if we have terms multiplied together, then we can split it up using addition. If we have division, we can split it up using subtraction. And then the log of x to the n with base b, this is just telling us we can take the exponent, move it down in front, and multiply it. And then here we have the log of x is equal to the log of x with base 10. In other words, if there's not a base there, remember it's understood to be 10. And we write it like this. We don't write it like this. You don't typically put the 10 there. And then this is natural log. This is ln, natural log of x. That's just the same thing as log base e. In other words, this log base e, ln is the same thing as that. It's kind of like an abbreviation, an abbreviated way to write it. And then this one, the log of b to the x with base b. What this is saying, if the base of the log and the base of the exponent are the same, then your answer is the exponent. Okay, so we're going to use this one to graph. Okay, we'll need this property here to do some graphing. All right, so let's look. Let's make an XY table. And remember what I said at the beginning of the video. This is just a review. All right, so I want to choose some values for x. So I'm going to choose 1. Okay, and after we graph it, I'll show you another example like I did earlier on how to pick your x values. But I want to choose 1 because I know the log of 1, no matter what the base, is 0. I know that value. And then I want to choose 3, 9, 1/3, 1/9. So what I'm doing here is I'm choosing some values that are going to give me positive answers, and I'm going to choose some values that give me negative answers. And I'll explain more about how I choose the I will explain more of how I choose these values, but then with those other examples, it'll clear it up. All right, so here I'm going to get y equals the log of 1 with base 3. We know that's 0. Y equals the log of 3 with base 3. Now remember, this exponent here is understood to be a 1. These two bases are the same, so my answer is 1. Y equals the log of 9 with base 3. Well, this 9 here, I can write 9 as 3 squared, right? And so these two bases are the same, so my answer is 2. And then y equals the log of 1/3 with base 3. That's going to be the log of, see, now my base is 3, so 1/3 I'm going to write as 3 to the negative 1. Remember, you can take that 3, move it up across the fraction bar, and it changes the sign of the exponent. So that's negative 1. Y equals the log of 1/9 with base 3. That's going to be the log of 1/3 squared with base 3, which is the log of 3 to the negative 2 with base 3, which equals negative 2. So you can see when I evaluated these, what did I do? I got them all in the form of this, so I could say my answer is just my exponent. Now, what do you do if you can't get the bases the same? Well, if that's the case, well, you should be able to get the bases the same in all of them by choosing those values, like I'm going to show you here in a minute. But so now let's go ahead and graph this thing. Let's see, I got 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 right there. We got to go out to 9 on the x values. 1, 2, 1, 2, and then we plot the points. Let's see, that's 0, 1, 2, negative 1, negative 2. So plot the point 1, 0, 3, 1, 9, 2, 1/3, which is about right in here. Let's say 1/3 for our x is about right in here, and that's going to be negative 1, and then 1/9, negative 2. And so our graph is going to look something like this. And the other thing you need to remember is your graph will never look like this. It'll never cross the y-axis. Remember, you can't take the log of 0 or a negative number. And you can test that out. Punch in the log of 0 in your calculator, punch in the log of a negative number in your calculator, and it'll return an error message. All right, so let me show you this real quick. What if we had something like log base 5? Let's say we wanted to graph that. And we've got our x, y values. How would we choose our x values? Well, our x values would be what? 1, 5, 25. This is a 5 here. 5, 25, 1/5, 1/25. All right? Because, see, that's 5 to the first. This 25 we can write as 5 squared. We can write this as 5 to the negative 1. We can write this as 5 to the negative 2, just like we did over here. So what would we do if we had log base 7? How would we choose our values? Log base 7. Well, we would choose what? 1, 7, 49, 1/7, 1/49. And that's what I wanted to show you. Choose your x values like that, and you should be good to go. Okay. All right, so we already went over these properties, so let's move down here. Now, this right here is just pretty much rewriting things. This is going to be using these properties here on rewriting, expanding, and condensing logarithms. I'm sure you remember how to do that from algebra. But in this problem, they want us to express as a sum of logarithms. Well, we only have one term here, but the 15, we can write that as the log of 3 times 5 with base 4. This is what they're wanting you to do. They're wanting you to break the 15 up into factors. And so this would be the log of 3 with base 4 plus the log of 5 with base 4. And this is what they're wanting in this problem. Remember, if you got terms multiplied together, you can split them up using addition. Now, what if we want to write this as a difference of logarithms? Well, that's going to be the log of 5 with base 4 minus the log of 3 with base 4. So remember, if it's division, that splits up using subtraction. And then this one, write this as twice this. Basically, what they're wanting you to do here is they're saying, okay, there's this exponent here. And remember, this property, where is it? This property right here tells us we can take the exponent and pull it down in front. That's what they're wanting you to get out of this. So we can take this 2, move it down in front. So that's 2 times the log of t with base 4. And that's what they're wanting there. All right. Now this one, they want us to write it as a single logarithm. So remember, if you have addition, see these properties up here, remember, not only can you go from this side to this side, you can also go from this side to this side. So if it's addition, that comes together as multiplication. If it's subtraction, that comes together as division. And then this shows we can take this number out in front and throw it back up into the exponent. All right, so before we combine these, the first thing we'll need to do is take this 2 and throw it back in the exponent. So that's log base 2 x squared plus log y. So all I did is I took this 2 and moved it back into the exponent. And now addition, that comes together as multiplication. So that's going to be log base 2 x squared y. And that's what they're wanting there. And then this one, write as multiple logarithms. So the easy way to do it is, if it's multiplied across the numerator, that splits up into addition. If it's going across the denominator, that splits up using subtraction. And let me rewrite this problem. Let's keep the z cubed, but let's go ahead and put maybe a w there along the bottom. Okay, let's split this one up. So this is going to be the log of base 3 x squared plus log y. And then if it's being multiplied across the denominator, that's going to have a minus sign in front of it. So that's going to be log, I forgot my base 3 z cubed minus log base 3 of w. All right, and so that's your answer right there. Well, not quite, but that's the first step on splitting it up. And then they want us to take these exponents and throw them down in front. So that's 2 log x base 3 plus log y base 3 minus 3 log z base 3 minus log w base 3. And there's your answer. All right. All right, so So that's condensing and expanding logarithms. And then we have this change of base formula. We've got log of x with base b is equal to the log of x with base b over the log of the log of x with base a over the log of b with base a. And I'll get back to this in a minute, but first let's just do a couple of more of these. I mean, we've already done them, but when we graphed, but that's 2 to the cube base 2. All right, we want to get the bases the same, this base and this base, so that's 3. This one, that's the log of 1/9 with base 3, which is the log of 1 over 3 squared base 3, which is the log of 3 to the negative 2 with base 3, which is negative 2. All right. All right. So with the first two problems, notice the bases of the logs and what we were taking the log of. We were able to rewrite each of these as the base of the log raised to a power. See how we did here? And so that meant our answer was just our exponent. But what happens if we have something like this? Can we rewrite 20 as 2 raised to a power? Well, we can, but it would take us forever to figure out what the exponent needs to be. The exponent would be a decimal, right? So we have this property right here that says we can rewrite it like this. But let me show you what I like to do. Let's just come down here and write it. Let's write our property. It says the log of x with base b is the log of x with base a over the log of the log of b with base a. That's the property. Now, this a here, you can make the base of that log anything you want. What I like to do is this right here. I like to write it as natural log x over natural log b. And why do I do that? Because it's easy to punch into your calculator. You have a natural log button on your calculator. So it would make it easy to evaluate. Now, another option, you can write log x over log b. So all I'm doing here, remember, ln is log base e. So I'm choosing a to be the e. So log base e. And you write it as natural log. Here, you're choosing the base to be 10. Remember, if there's not a base, it's understood to be 10. But this is the one that I typically rewrite it as. And so this would be the natural log of 20 over the natural log of 2. And so then you can punch this into your calculator, and let me do that. So that's going to be natural log of 20 natural log of 20 divided by natural log of 2. And that is going to give us 4.3219. I'll just round it to 4 decimal places. But yeah, there's your that's your answer right there. All right, so like I said, I'm not teaching you logarithms in this video. It would be impossible to do that. There's, in the applied calculus book, there's one section on review of exponential and logarithmic functions. So obviously, if you were learning this in algebra or something, pre-calculus or whatever, you would be spending several class meetings on this. Okay, probably 3 or 4 class meetings. So this is a review saying, hey, remember this. That's all I'm doing on this video. All right, so I hope the video helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I'll see you in the next one. Later.